When we're looking at how far left and right things go, so as we're moving this, we're expanding how far left and right. Now, this graph is going. Okay? That gives us our domain. So this one is zoomed out. Notice we've got really far left and really far right as we're going along. Okay? So as we continue to go further left from here, we would continue to be going up further. And as we continue to the right here, we would be continuing to go to the right further. So it continues all the way to the left and all the way to the right. So that gives us that our domain value, and same thing here before we go into the domain value, as we go further left, the graph will continue going down. As we go further right, the graph will continue going down. So again, when we're looking at how far left and right things are going, we're looking at what the domain is. So our domain is always looking at how far left and right. So if we look at some of the graphs that we did before, so notice here, this will continue to go all the way to the left and all the way to the right, all the way to the left, all the way to the right, all the way to the left. Even though this one's skinnier, it will still continue to go out as it's going up, albeit it'll take it longer to be going out further. Okay. This one, even though it's opening down, will continue to go left and right, and we will be going down. Same thing with this one. So what happens is on our quadratics or our parabolas, we have the same domain for each kind of thing, because remember how we talked about there's a parent graph and then there's all the different transformations you can do with the parent graph. So here, all of our domain is going all the way left and all the way right. So we can represent that with this, it's like an italicized R. This stands for all real numbers. So all of our real numbers, which are all the way to the left and all the way to the right. Now, if we're saying all the way to the left, we have something that we call interval notation. So in math, when we're saying all the way to the left, all the way over here, if we keep going for forever, the way we say forever in math is infinity. So if we're going all the way forever to the left, we're going to negative infinity. So we are going all the way to the left, so to negative infinity. And then as we're going all the way to the right, we're going to positive infinity. So this is what we call interval notation. Now, the rounded parentheses show that it's not equal to it, or we always use it with our infinities. Okay? So our domain for all parabolas, all are negative infinity to infinity. Same thing with our lines that you've done before. Our lines are always going all the way to the left and all the way to the right. Now we do have things that have just a partial domain. If we go back and we look here, you can do where you restrict the domain. So we have just a portion that you can look at here, right? So I moved that one so far that you can't see. So I could just look from this part here at 0 all the way to infinity, or I could only look at from 0 to 10 and just do that portion there. So you can do just a portion of it and not do the whole graph. Okay? But in general, when we're looking at our parabolas, unless there's some kind of restriction that's been put on it, our domain is always negative infinity to infinity.